even if you spent a lot of time working in SQL, you may have missed this one.
All right. So alternatively,
probably
if you
first
have
4 or
spent a
5
lot of
years
time
of my
in
career,
Oracle,
because I was solely
you may
in
have already
Microsoft
encountered this
SQL
one.
Server,
And if
didn't
you
get much into
have,
Oracle,
then
and
I
this
would
is
love to see
primarily
your
where you
feedback
see this,
and
but it could be
hear
used in
what your
any of
practical
the
uses
SQL
of this
engines.
particular
So I'm super
function
excited to
is.
go over it with you today. It has a lot of practical uses, and it's something that early on a lot of people miss, and even some seniors still don't know. So today we're going to go over something that you may encounter from time to time, especially as you're refactoring old code, or it's very useful, it has a lot of practical uses, and that is where 1 equals 1. This is super cool. It gets used a lot. I'm going to give you some real practical uses, and at the very end, I'm going to give you one slight moderation to that even if you have been in Oracle SQL, you may have missed. All right, so what is where equals 1 equals 1? What does that mean? 1 equals 1 evaluates to true, right? Because 1 equals 1. So it's a condition, always evaluates to true, and at first glance, it really may seem redundant and really something that is just a waste of space and processing time. So why would you include something like 1 equals 1 in your query? The magic of 1 equals 1 lies in its utility for dynamic query filtering and dynamic query building. It's really useful when you're using Python to construct your SQL statements, or if you're doing some type of dynamic pipeline building and you need a base query and you're going to add on additional where statements on top of that. And you don't know if it's going to be the first one or the last one. And instead of evaluating every time, does that one already exist? You just know that it does. So here's an example. As we see here, select all from sales transactions where 1 equals 1. And then we have a couple of additional where criteria here. One filtering the transaction date and one filtering the customer segment. And so we're looking for all of our transaction dates greater than or equal to January 1st, 2024, and our customer segments equal mid-market. So why do we include where 1 equals 1 in this case? The answer is simple. It makes your query easier to modify dynamically, and if you're writing code that builds SQL statements based on user input or some type of other conditions, I once had to build a pipeline where we would prompt the user via a Power App various conditions, and then they would hit the submit button. It would feed those parameters back into the the ADF pipeline, and the ADF pipeline would use those to dynamically create the statement for the transformation that needed to occur. So that's one practical use that I personally have used before. So in this case, if we are testing things, it's very easy in this case to comment out one of those lines. It is, again, very easy to add additional lines. And again, it really makes it much more dynamic. So it really allows you to easily append additional filters without any concern about whether or not the where clause already exists. And here's another dynamic query example. Where we have a query statement, the beginning of our query statement, again, select all from our sales transactions tables, where 1 equals 1. And then we have some if statements here. All right, what you're looking at here is a Python statement where we have created a base query. So you see the parameter query where it equals select all from our sales transactions table where 1 equals 1. So again, that is our great new method that we just learned. Now, we're also looking for a start date and a customer segment parameter that's being fed into this Python script, presumably at this point. So this can be fed into Python script via Power App or some other process. But if there is a start date that exists, then it's going to append to that base query and transaction date is greater than or equal to start date. And then if there's also a customer segment, then even if there's not a start date, it's going to append and customer segment equals customer segment, whatever gets fed in. Next, we're going to go over that extra super secret use case that I was talking about. That's a little bit of a twist from this. All right, where 1 equals 0. you might be asking yourself right now, what the heck is going on here? So where 1 equals 0 always evaluates to false, right? Because 1 does not equal 0. So again, always evaluates to false. At first sight, this really might seem completely useless. Why would you intentionally write a query that returns no rows? Well, I've used it before to create staging tables based off of production tables. Or copies of tables. Say you needed some type of temp table that's based off of an existing table that you already have, you could do that and use this where 1 equals 0. So that's the practical use case. So we have this query here where we have create table staging.sales transactions and we have our select customer ID, transaction ID, and transaction amount from our sales transactions table where 1 equals 0. This way, it's not going to populate it with any fields, any rows. It's just going to create the structure, the schema of that table. So let me know down in the comments, what other variations of this have you seen? I'd love to hear what use cases you've used this for, and love to hear your feedback in your comments. I've even gotten some feedback that even though they've seen it practically out in the wild, they still don't like it being used, so they don't think it's great. So I'd love to hear your feedback, love to hear different points of view, and let me know. This last part, we're going to talk about tackling the SQL quirks and your tech debt that comes along with using some of these SQL quirks. So where 1 equals 1, where 1 equals 0, the true, the like, create table like, are just some of the examples that you may see and SQL patterns that might seem odd at first, but really have some practical use cases out there, and you'll see them out in the wild. They're also a great reminder that sometimes the quirks of SQL really have some practical purposes. Some of the creative workarounds that are out there have some really grounded practical use cases. So these are just some of them that you may run into over time. But this brings up really an important question. How do you handle SQL quirks when managing tech debt? Let me know down in the comments how you do that. But I'm going to cover a few things that I do when I am working through, especially working through refactoring things and when I'm writing my code. So how do you handle the tech debt that comes along using some of these quirks? All of us, all the data professionals out there, whether you're an engineer, an analyst, scientist, you've inherited some type of messy quirkiness, some type of just weirdness that you've come across that someone really came up with a very creative solution to a problem. But it may be confusing and you may have to untangle some things to understand it. And so understanding those patterns like these that we went over today can really help you decipher some of the older scripts that are out there and some of the things that you'll inherit as you move into some of your roles. So again, let me know down in the comments how you handle it. These are the things that I do to handle some of my tech debt. So the first thing that I do to handle some of the messy tech debt, especially when I am inheriting somebody else's script, especially oftentimes I've had this one script that I had was over 4,500 lines of code of SQL, just pure SQL, to go through and clean all this data and to create these models. And it was really complicated. There were a lot of things in there. There was a lot of hard-coded business logic that I really had to unravel. So when I'm doing that, the first thing that I do is the parts that I need to unravel is I'll take them out step by step and just grab that part that is pertinent to what I'm trying to unravel and run that separately to try and test it, see what comes out, see what the results are, see what happens when I remove things and change things around, and see what those impacts are. So that's the biggest thing that I do. And really, it's kind of my first step in troubleshooting and examining the new script that I've inherited. So the next thing is old school. So old school, we have Stack Exchange, right? It really old school. We didn't have Stack Exchange before that, but we have Stack Exchange. Stack Exchange is out there, and I've posted stuff on Stack Exchange. I've looked up stuff on Stack Exchange. If you are a data engineer or a programmer, you have probably used Stack Exchange at some point in the past. So Stack Exchange is always a great resource. If you're going to use it, be sure to anonymize anything that you do put out there. You don't want to share any proprietary secrets. You don't want to share any potential credentials or anything like that. But you can kind of cleanse it and put it out there, and there will be good, bad, or indifferent feedback on what that looks like for you. So now, next step. If you don't get anything from, troubleshooting and taking things out piece by piece, you don't get anything from, Stack Exchange. I'll go into some new school options here in a second. But you can always use a phone friend, right? Phone friend is something, super old school, right? You turn around and ask one of your coworkers, or, do a video chat with one of your coworkers, share a screen. I had a friend, his name was Lee, and we used to call it the Bat Cave. We used WebEx at the time, and we named one of our WebEx rooms the Bat Cave, and we'd go to the Bat Cave and figure it out. We'd hash it out. And so that was, what we did. Reach out to a mentor, reach out to a coworker. If you have a programmers group that you go to, reach out to them. Use those resources. Other people have likely run into it if you haven't before. Okay, now new school, we have these amazing tools more recently, right? Like we have Copilot, we have ChatGPT, we have Anthropic's Claude, we have DeepSeek potentially. And so AIs really do a great job of reading the code and giving you a synopsis, just an explanation of what is going on in that code, especially if you ask it. And it will give you some alternatives, and you could kind of brainstorm. Again, don't take everything from AI as gospel truth. Be sure that you evaluate it on your own, using your own background and history, and you could learn from it. And it's great for troubleshooting these types of issues. So those are the steps that I use to troubleshoot. Again, I'd love to know in the comments what steps you use to troubleshoot, what sites or what resources that you use to troubleshoot when you run into code that you've inherited that's kind of messy, that you don't know what to do with. Now, final step is, final thing, when you are handling the tech debt and you are looking at old code and you're refactoring things, or when you're writing things, if anytime you're using a quirky workaround-ish type of thing, be sure that you document. Because for two reasons. One, somebody else at some point is going to take over that code and have to look at it and figure out what's going on. You want them to be able to do that. The other thing is that 6 months, a year, 3 years down the line, when you have to look back at this code because something changed or something broke or something needs to be improved, you are probably not going to remember why you did that workaround. Be sure that you document clearly so that you understand and other people understand what's going on. Okay, so tell me, what SQL quirks have you run into or that you use? I'd love to know. I love learning about all these little things that people have come up with over the years. So let me know down in the comments. I love this type of thing. It's one of my favorite things about collaborating with other people, because everybody has a different approach, everybody has a different perspective, and I love hearing about what other people have come up with. Have you inherited things that you thought were just brain numbing or just baffling, and you're like, why in the heck, and still are like, why in the heck did they even do that? That just made it worse. I'd love to hear those stories as well. We all have those stories. We all have those horror stories, again, about the 4,500 lines of code that a bunch of stuff was hard-coded in it that we needed to refactor. So let me know down in the comments. And, again, I love that our community continues to grow. Keep in mind that on Friday nights, we do a live session at 10 p.m. Eastern time. If you have any SQL questions, Python questions, general data engineering career questions, we talk about those on Friday nights, live answering your QA, any questions that you may have. And if you enjoyed this, if you enjoy the content, be sure to like and subscribe and watch our other videos. There's a lot of content that I've put out there, a lot of good information, and let me know what I could do to help you further your own careers. Thank you, and I'll talk to you next time.